Alright, so we're looking at day 1 of Unit 9. I am recording for vectors, okay? In case you need to go back and watch this video, guys, over the next couple of days, because you should have picked up this homework assignment that is due on Friday. It's very easy. A big part of what we do today, pretty much all of what we do today, is the homework assignment. And again, it's pretty easy if you understand what's going on. So let's go ahead and get started. So, what is a vector is the first question. A vector is a direction with a distance. And if I were to say, give me an example, it's all about this. Guys, you are always going to imagine that so a lot of teenagers think the world revolves around them. During this unit, the world revolves around you, okay? So you are the origin. So if I said, if you're here and you're facing this direction, and this is like an aerial shot from above your head, so you got your little shoes there or whatever, and then your arms and your shoulders. Let's say that you have a backpack. And not too bad, right? And I said, from here, you are going to travel, and some of you are going to think differently as far as the orientation. That's what vectors is all about. You're going to travel at a 45-degree angle for 10 miles. What you should have drawn would be something that looks like this, where you start at the point, and the direction you're headed is what the arrow will show. And you've traveled 10 miles. Okay? That's a basic vector. Well, here's the thing. What if I said you weren't here per se at the origin, and I said that you were over here, and I told you to travel the same vector? That means you could be over here, and it's basically the same exact thing, only in a different location. Now watch this. A vector has a distance, and it has a direction. Now this is huge what I'm about to say. The direction is always in respect to the unit circle, as if this was 0. You with me? So if I said you're traveling at a 45-degree angle, this angle is 45. Is this traveling at a 45-degree angle, yes or no? Yes. It is. Because like I told you, the analogy is this. You are the center of the universe, where you are now the origin. So from you, you're going to create all these mini origins that from 0 degrees from where you're at, this would be 45 degrees. Okay? Let's do some more to understand what's going on. Here we go. So the magnitude is the length. And the way I want you to show the magnitude, it looks like this. It's not the absolute value of velocity. It's not the absolute value of v. This is how we notate the strength or the length of a vector. Because in vector notation, what's cool about vectors is you can look at this and say, I'm traveling 10 miles. Or you can look at this and say, this wind is traveling at 10 miles per hour. So a magnitude can be like a velocity, but it could also just be a distance. You with me? Two different representations of magnitude per se. So direction is going to be theta. Theta, let me highlight it in green, is what we were showing over here as, in reference to the nearest x-axis, what is that angle going to be? Now, I'm serious. This unit has a lot of real-world application, and it can be very easy, but when we start doing two vectors adding or subtracting with one another, the real-world application makes sense, but the math, you just got to be careful. There's a certain kind of order that you go in order to get the answer. But seriously, it's a lot easier than last unit. Okay, let's go to see what they say vectors are. So this is the quote-unquote
name of vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Magnitude is strength
Vector!
or distance?
As I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? Now, he represented by an arrow with both direction and magnitude.
Hold up. Let me see if I can pause it.
Vector! That's...
Nah, it was a little bit back. Right there. So, a good way to remember the difference between a point and a vector is this right here. So, a vector is going to have those notations, but like this. So if I wanted to say 4, 2 as a point, 4, 2 as a vector is now going to be something different. And this is something huge as far as the difference between points and the difference between vector notation. Let's talk about that. For instance, these are called components. So looking at this first one right here, components are A and B. Okay? And the way you can get A, which is the x value, is simply by multiplying the magnitude times the cosine of theta. So this is huge right here. This x value can be obtained by multiplying these together. The y value can be obtained by doing the magnitude of the vector times the sine of the angle. And the reason of that being, guys, is because, look, you've done this before. Sine is y. Cosine is x. And that vector is like r. It's like the strength of the radius, if you will. So what we've done before, you can think of these v's as r's. And the time we've done that was when we were doing linear velocity. Remember, as far as the angular velocity, like a merry-go-round was going around and round, the further away you were away from the center, the bigger the number was. That's the same thing here. Depending upon what this vector's magnitude is, will give me what is that x value there. Now, check this out. I'm going to show you at first, and then you're going to quickly pick up on it. This notation, don't let it confuse you. It's too much. It's too much. x2 minus x1, it's just saying, whatever this x, let's say that this was 0, 0, and this was 1, 2, 3, 1, 2, 3, 4. So it was 3, 4. All it's saying is, if I want to know a vector's component, 3 minus 0 is 3. 4 minus 0 is 4. But it's not a point. It's a vector. Now here we go. Let's say that, how can I do this? Let's say that I want to use vectors on the football field. Let's say that here's the bounds, I'm here, say these are the hash marks or the seams. And I have 3 wide receivers. And here's me all-time QB, because I'm not running. Alright. So I tell these guys, they know vectors, and I don't want to tell the other team what we're doing, but at the same time I want to call audibles really loud so that they can quickly know what they're doing. The first guy, I say, your route that you're going to run is negative 210. The next guy that I say, you're going to run, let's say, 0, 3. And the third person, I say, what you're going to do as far as running, you're going to go, let's say 5, 10. Okay, look what's happening. Each of these will have their own origin, and they're going to run a route, and we're going to do this if we have time next when we come back from spring break. We did this last year for the first time. No, last year was the second year. The first year was 2 years ago, and there was this kid that ran a route, and I gave him something ridiculous, like 2 and 20. And he ran that route, and when I threw it, it was an overhead catch. And unfortunately, he landed on his stomach, knocked his air out, but we had to come back inside. Anyway, and I just recorded that. All right, so looking at these routes, I'm telling this guy right here to run a -210 route. And what that means is from where they're located, as their body is facing forward, they're going to imagine -2 to the left because that's X, and then they're going to imagine 10 up because that's Y. But what they actually travel is only this right here. That right here is what their vector is traveling. So when I say someone, hey, -210, they're doing this right here. And only that. It feels like a lot of rise over run going on, but it's X and Y components. You with me? So now start envisioning this. I want you to run a 0-3 route. So you're not moving X-Ys, but you are moving Y-Ys 3. This dot is very important because it tells you what? Where you start. Where are you starting? This arrow tells you what? The direction. Where are you going? But the magnitude, I have to find the magnitude. Remember? It said has direction and magnitude. If I wanted you to tell me, let's do this last one first. 5, 10. So 1, 2, 3, 4, 5, and then up 10. This person's going to run a route like this. What I don't want you thinking, I'm going to do it in red, that this route is ran. That's not what's ran. That's what's happening simultaneously. As you are running this route here in green, you're thinking, I got to be 5 over and 10 up, but I got to run this straight line. That is the vector, the component route. You with me? Now, with this being said, let's use this right here that I just did as an example. If I asked you, how far did this person actually run? And I wanted you to tell me how long that was, what could you do? Pythagorean theorem. You have 5, you have 10, so it's 125. That's going to be square rooted, and whatever that is, that's how far that magnitude is. It can be a distance, but it could also be wind. That wind is traveling at, someone handy with the calculator, can you help me out please? What's the square root of 125? 11.18. We could say feet. So that person is running a 5:10 route, and they're running 11:18. That's the distance that they run. So at 11:18, that's when they're catching the ball.
If it's like a restricted length, why don't you just use like another point at the end instead of an arrow?
Because with vectors, the big thing with vectors is we have to see where is this coming from. Where is this strength or this wind or something coming from?
So you just have to see the difference between them.
Yeah. So that's a really good question, and let me show you kind of real world example of what I'm talking about. Let's say that, right? And I'm right here. These are the kind of wait, what? We're going to show if I'm lined up right here, and I'm kicking the ball, but I have a wind that's coming over here at 5 miles per hour, or we're going to call this just vector A for air, right? And this is how you'll do it, vector A, that if I kick it straight and I aim for this pole, or even just a little bit to the right, depending on how far I'm kicking it, and with what strength, what magnitude strength that my foot has, will tell me, is it going to go here, or is the wind going to carry it and it actually go over here. So you're going to be able to, at the end of this unit, know how to overcompensate and beat this wind, so that if you want the ball to end up perfectly here, you would be able to know what direction or angle am I going to kick it at, and with what strength am I going to kick it. Because if I don't kick it hard enough, it's not going to reach the goal. And if I kick it, depending on my angle, the wind will help. Now, I know I jumped to one of the big involved questions, but I feel like you guys were already getting it. Now look, here is what I'm aiming to kick. This, to the left, is happening as soon as I kick it. And it's happening at a constant rate. So will my ball do this? The answer is no. My ball will still travel at a straight line, but because of this wind, it's happening at the same time. As I kick it here, the wind is blowing here, and what you will actually see on videotape is the trajectory right there. So it's multiple forces acting on something at the same time to tell you where is that ball or that rocket or whatever it is that you're doing, where is it going to end up at? Now that's at the end of the unit. I just wanted to show you where the use of this is for. Alright, let's go back to the basics. So what is the component? How would you write this one's component? You'd write it as 3, 4. That's basically the route. Now, this is important. If you're here, and that's where you start, what are the components of this next vector? Positive 3, and then negative 3. Guys, this is very important. This is why I wanted you not to memorize all students take calculus. I wanted you to memorize this. Whoops. Because look, if I have something that has a positive, it's going to appear that it's traveling in the first quadrant. Does this look like, if I made the whole world revolve around me right here, is it traveling in the first quadrant? Yeah. Look at this next one. You have a positive x and negative y. If I made the whole world revolve around me right here, is it traveling to the fourth quadrant? Yeah. So location is huge as far as orientation. So, I mean, if you're a pilot, if you're a captain of a ship, they use this all the time with navigation. Okay, there's many applications with vectors. Next one, magnitude. We've already talked about it. And guys, you're looking at these basic notes now because of what we've talked about, and this is just making sense. A are the x components, and B are the y components. So here we go. The same thing, but I'm asking you 1, 2, 3. That's 3 over to the right. 1, 2, 3, 4. That's up 4. But I want to know, what is the magnitude? So it's like making a little mini right triangle and just doing Pythagorean theorem. It's going to be a 3, 4 what? 3, 4, 5. So I almost said it wrong. Not the absolute value of v. The magnitude of the vector is 5. Units. Please put units. If you don't ever see feet, if you don't see centimeters, put units. And if you don't, I'll take off on the quizzes and tests, okay? Because units are important. Because units could be miles, or it could be miles per hour. Okay? We have to know what we're talking about. Alright, someone give me the components for this one. Remember, you're the dot. You're the dot. So if you made the world revolve around you, it'd be -4. And what was the other one? -1. They're the components. And now if I told you I want to know how long that vector is, you would say x plus b, Pythagorean theorem wise, and you would get what? Those of you handy with the calculator, if you could do that. The square root of what? 17, which is 4.123. Really? That's cool. Units, or root 17. Easy, right? Okay. Let's go to direction. This is the one people struggle with. But let me show you the easiest way that, okay, this is why people struggle with it. Look at all that. Ain't nobody got time for that, okay? So I'm going to simplify it for you, and if you don't understand what I say, you have to do this, okay? So the direction is this. From wherever the vector's going to the closest x-axis. So if the world revolves around me here, the direction angle is going to be right here. Nice, nice. Reference angle is what this is about. It's just the absolute value or the positive reference angle of anything. And you're going to see how some of them are different here in just a bit. So let's say I had this one. We know the components for this are 1, 2, 3, and then up 1, 2, 3, 4. So we have a 3, 4 vector. These are the components. The magnitude is going to be 5. Oops. So we're going to say magnitude is 5 units. And here we go. The only thing that I really want you to use is this right here. Okay? And like Jacob was saying, we're gonna try to find it as a reference angle. So here we go. The arctangent. Question for you. In this context, will it always be arctangent? Yes, because you're given what? An x and a y. An arctangent of y over x, right, is going to be 4/3. Will get you that angle. So in the calculators, please, go ahead and do this, and do it in degrees for me, please. I want you to type in the arctangent. Again, put it in degrees, please. So home 5.2, change it to degrees, make it your default. Home 5.5, go ahead and sign in if you'd like to, you don't have to. But I think I'm going to sign in just so that I can show the people who are watching this video as far as what it could look like on the calculator. Alright, here we go. So I'm going to capture my screen and then present it. And what we're going to do, guys, is we're going to do the arctangent. Notice that I am in degrees of control divide 4/3. If you struggled with calculator usage, please look at these videos for the next test, okay? If you struggled with calculator usage last time. Now, this is a positive 53.130. So if I go back over here, I'm saying that this is a positive 53.130, again, 3 decimal places. And would you trust that? Looking at the picture, would you trust that this was a positive 53? Yeah. Okay? Now, if we do it here, the components of this one over here are going to be 0, -3. Okay, that's how long that magnitude is for that vector. And if I do the directional angle, it's going to be the arctangent of -3/0. And guys, if you are waiting for your homework to practice this, you're going to miss a lot of stuff. That's why I really want you to do it with me in class. The arctangent of -3/0, let's see what we get. control negative 3 over 0, we get plus or minus 9. And now people should be like, wait, what's going on right now? Okay, so here's the thing. We know that this angle is either going to be 90 or that this angle is going to be a negative 90. Which one does it look like it's traveling from what you're looking at? Negative 90. So the direction, here we go, is negative 90, or, someone said it, you could do plus 360, which would get you what? 270. Okay? You with me? We're going to do a little exercise right now. Okay, let me pause the video and go ahead and stand up, please. So back. We know, okay, so here's the answer. Negative 90, and this is why I wanted you to do that activity, because some of you will put negative 90, and others are going to put 270, and you're both going to be just as correct. Okay? Let's move forward. Here we go. Let's do Q first. Q. Now, again, I am encouraging that idea of the world revolves around you during this unit, okay? So at Q, here is where I'm going to start. My components, the signs should be what? Positive, positive. Based off what I just drew right there. You with me? Now, this is my origin. So what route, the analogy that I've given you with vectors, would Q be? 4, 3. If you write 4, 3 with parentheses, I will deduct points. Please don't do that. There's a huge difference. 4, 3 is this. What you actually did. As far as if it's a vector, that's 4, 3. But if it's with parentheses as a point, it's just a point. And it's not even there. It's over here. 1, 2, 3, 4, 1, 2, 3. This is where 4, 3 would be with parentheses. Notation is huge, okay? All right. So, Q is 4, 3 without those parentheses. All right. Magnitude. What do I do with what I've drawn right here? What do I do to get magnitude? 4 squared plus 3 squared, take the square root. So a squared plus b squared, take the square root. So 16, right? 16 plus 9, I'm just showing the work, is 25, so we know it's going to be 5 what? Units. Good. And then the direction. We're going to think about this, and again, I want you to do it my way rather than memorizing all that other stuff, and what Jacob was saying as far as the reference angle. So let's get some practice. We're going to take the arctangent of y over x. And that was from what we got over here. And in my calculator, if I go to the calculator and put 3 over 4, the arctangent of 3 over 4 is going to equal 36.870. So 36.870 degrees. Now watch, I'm about to highlight it. That means, this is why I have that activity with you guys. We're always going to talk about 0 degrees. So from 0 degrees all the way to the angle, does this right here look like it could be 37 or 36.870? Yeah. So that is going to be the direction that you travel. You with me? Now another way that you could have done 36.870 is, what if we went this way? I would just subtract that from 360. So subtracting that from 360, this is where people are going to be different. I'll get 323, but a negative 323.130. You with me? A negative 323. So it could have been this or negative 323.130 degrees. Either one will work with what we're going to do with these. Are we good? Okay. let's now go to R. I'm going to erase this just so you don't get confused. And let's go to R. Now, I'm not going to write it this time. I'm going to see if you can envision where the world revolves around you by making you the origin, and you tell me what's the route. What are the components for R? Negative 4, 4. Nicely done. It's always the x first. So what would the magnitude be? It'd be the root 32. So it would be 4 squared is 16 plus another 4 squared is 16. So it's root 32. But do you think we're going to let you just write root 32 units? No, we're going to have you reduce it. So root 32 is the same as 16 times 2. And this 16 will come out as a what? 4. So you have 4 root 2 units. Or if you want to put the decimal equivalent, that's fine. But you got to know both, okay? Please do not sell yourself short on reducing radicals or simplifying radicals. Here we go. The arctangent of the y value, which is positive 4, over the x value, which is negative 4, whoops, is the same as negative 1. And if I go to my calculator and I do the arctangent of negative 1, this is where it gets a little interesting. The arctangent of negative 1 is going to give me a negative 45 degrees. Negative 45 degrees is what the calculator tells me. Guys, negative 45 degrees would be if I was traveling this direction. But R is not doing that. Jacob said it. We need to look at this angle no matter what it spits out. We need to look at it as a reference angle, meaning make it a positive. That means, watch, if this is my origin and the world revolves around me, a positive 45 is from the vector to the nearest x-axis. This is huge right now what I'm showing you. So if I make this into a positive 45, that means 45 degrees is between the nearest x-axis and that vector. But the direction that I'm traveling is from 0. So what am I going to do? I'm going to subtract 45 from 180, right? So that I could see what is my actual answer to tell me what direction am I traveling. So the answer should be what, guys? 135. 135 degrees. And just like the activity, whenever I said we were facing forward, and I said, hey, I want you to travel wherever 135 degrees would be, you always have to go back to 0 and then find 135, move your body, and then walk. That's a lot better, in my opinion, than trying to memorize all those other things. Okay? All right. Let's look at S. Okay, we're going to pick up the pace just a little bit now that we've gotten the basics. So S, what are the components? 0, negative 5. So 0, negative 5. So what would the magnitude be? 5. Because a squared plus b squared, take the square root. What direction is S traveling at? 270 or negative 90? Just to remind you, I'll put the negative on there, okay? But all of these could be negatives. We know that. Okay. T. What's T's route or components? 4, 3. We've done this before, haven't we? T is very similar to what? Q. And the direction, what do you think the direction would be? The same, 36.870. Remember, it's always from the nearest x-axis as far as the orientation is concerned. U, what vector is U? What are the components of vector U? 2, negative 2. Nicely done. And the magnitude? Can someone do that without a calculator? Nicely done. So Negative 2 created this right here. 2 and a negative 2. And that's x root 2. 45, 45, 90. Remember I told you to memorize that when we first started doing trig? So that's going to be the same as 2 root 2. Okay? So we'll put 2 root 2 units. What is, now listen, if I did what I'm supposed to as far as the arctangent of y over x, which is the same as arctangent of negative 1, your calculator the last time gave us what? Negative 45. Could you put negative 45 degrees for u? Yeah, you could. Or, because remember, it's to the nearest horizontal, which means this. This angle would be negative 45. You've got to start at 0 always. Or, what could you put if it was positive? 315. Either one will work. To me, I like to do the positives no matter what. Okay. Let's go to V. V is going to be, it looks like negative 2, 1, 2, 3, 4, 5. Negative 2, negative 5. So 25 plus 4 is 29. And whatever that is, let me go to my calculator real quick. The arctangent of this negative 5 divided by negative 2 gives me 68.198. 68.19, let's say 9, let's round it up. But guys, V, let me put it over here. The world revolves around V right here. This angle is right here. To the nearest x-axis representation. So what am I going to add to this to tell me what the direction is going to be from 0? What am I going to add to it? Yeah, 180. Because from 0, 180 plus that would get me to 248.199. And if I subtract that from 360, I could put negative 111. Okay? Negative 111.801. Either one's going to work. Alright, almost done. This will be the last page of notes. Alright, so, check it out. Here's your x. Here's your y. And then here's your magnitude. This magnitude, please, 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 these are not equal at all. The absolute value of v is not the way you should read that. This is saying the length of the vector. The magnitude of the vector. Right? The strength, all that other stuff. Guys, what does this represent? So think of it this way. This one that I highlighted in blue would just be the picture by itself. Just draw it. If I asked you how long that was or what strength that was, as far as units are concerned, that's what this is talking about. And you do Pythagorean theorem for this one, not for just V. Okay? Alright. Let's go to, how do you find the, what's cosine? Do you all remember what cosine was? Like, x over what? It was x over r, right? With the unit circle, it was x over 1 because the radius was 1. So if it was x over r, here, r is, doesn't this look like a radius? So it's like saying that the range, or the radius, is this right here. The magnitude of the vector. So if I multiply both sides by the magnitude, get this. The magnitude of v times the cosine of theta will give me an x value, because cosine is x. We know that sine is opposite, or y, over the magnitude. So that if I did magnitude times sine, and you'll see this on your homework. you would be able to get the y value. The y component because sine is y. Let's do some example problems. Look at number 2. It says, solve these equations for x and y to create formulas that will allow you to find the components when the magnitude and direction are known or given. Here we go. I have the length of this vector right here is 12. And it's traveling at 60 degrees. You with me? So if I wanted to know what are the x and y components of this vector, how do I find the x? How do I find this value right here? I'm just going to multiply the magnitude times the cosine of theta. So 12 times the cosine of 60, let's see what we get. And we have to be in degrees. 12 times the cosine, because cosine is x, of 60, and it's going to be 6. So it's going to be 6. Now let's figure out the y. The y is going to be the magnitude times the sine of 60. So 12 times sine of 60 now is going to give us this. So we're going to say 10.392. Let's go 3 decimal places. You with me? So guys, this vector in green, it ran this route. It ran 10.392. Does that make sense? And you're going to do the same thing over here. You're just going to do over and over the magnitude times the cosine of the angle to get the x and the magnitude. And if you can do that real quick, what would y'all get for the second one? What are the components here for the second one? I wonder if she has the key right here. Oh, cool. She does. All right, so G is negative 6.928 and negative 4. And that makes sense because they're both negatives. Because if they're both negatives, they should be traveling in the direction of quadrant 3. Here, one was a negative x, positive y. That makes sense. That's why it's in quadrant 2. You see how we're doing this? And then this last one will be like positive x and negative y. That's why it's traveling in the direction of quadrant 4. Are there any questions before we finish? If not, that's a solid start. That's a good start to the vectors, guys. 3 things: components, direction, and magnitude. So what?
Doesn't have the vectors.
Who doesn't have? Oh, she does. What are you talking about? They're right there. They're like weird, but yeah, they're there. They look like parentheses, but they're V's. Alright, cool. We're done. Again, this will be online in case you need to watch it again.